Our next speaker is Dr. Pierre Martini, who will be discussing conflicting objectives in water resource management. Pierre, pronouns he, him, is a professor of mechanical engineering, teaching classes primarily on advanced materials and engineering design. He works on short-term energy storage solutions, specifically energy storage flywheel systems for applications such as public transit and electrical vehicle charging. He enjoys skiing and is an avid cyclist on and off road. So thanks for being here, Pierre, and please go ahead and share your presentation.
Thank you so much, Amina. Yeah, thank you everybody for being here today. So today I want to talk a little bit about this, an experience that I had a few years ago. Let's see if I can get my slides to work. Here we go. So a few years ago, I was invited by Greg McDermott from the University of Calgary, the Department of Geography, to join a tour up and down the Kananaskis Valley. And so, as Amina said, I'm a professor and a researcher working in energy systems. And so I thought I had a good idea what an energy system actually is. So when he told me that this is a tour about the hydropower system in the Kananaskis Valley, I thought, oh, that's really interesting. Like, I want to see that, and felt pretty confident that I will understand what is going on there. So we all know where the Kananaskis Valley is, probably, like it's just west of Calgary. You know, it's a beautiful area, and if, you know, many of you probably have been there and toured around and maybe went hiking or other activities in the mountains there. And TransAlta actually operates 4 hydro plants in this valley. So they're not easy to find, but they are there. And so they are at the upper and lower Kananaskis Lake, at the Barrier Lake, and then very close to Trans-Canada Highway in the Bow Valley. And so these 4 plants have a capacity of 54 megawatt. And if you do the math, they do actually create about 170 gigawatt hours per year of electricity, so energy, you know, over the whole year. And that kind of accounts only for like 30% like time of use of these plants. So they're not operating full capacity all year long, which, you know, I get to in a moment. For comparison, I always, like engineers, always throw these numbers around. I just kind of try to put this in perspective. So for example, TransAlta also runs a large coal and gas power plant in Wabamun, here not far from Edmonton. That facility has 800 megawatt power. So it's significantly larger. So we see this is like, you know, like this is only a 16th, if I do the math right here, the hydro plants in Kananaskis compared to this large coal-fired power plant or coal and gas-fired power plant. If in another, like, you know, if you go to renewable systems, in Pincher Creek, like one of the wind facilities that is there, the Summerview one, it's like 38 wind turbines, so it's sizable, it's not small, right? So this has about this like roughly similar power output, like 68 megawatt. And for comparison, like the city of Calgary, on an average, over the average of the year, the city of Calgary needs about 1,400 megabit of power to operate. So this hydropower system in the Kananaskis Valley is small. It's not a massive power system, right? But it's nice. So there are the 4 hydro plants. There's one, and the first one is called the Interlakes one, that's highest up in the mountain, and then Pocatera, it's a little bit lower at the lower Kananaskis Lake, and then there's the Barrier Lake plant and the Kananaskis plant, and that's the one close to the highway number 1, the Trans-Canada Highway. So as an engineer, I thought like, well, that, you know, I totally understand what those are for. They're not there to generate power on a constant basis. Those are like, these power plants are there for peak power generation. So if this, you know, you probably remember those days in the summer when it was really hot and everybody had the air conditioning on, especially in the evening, and then our power grid is like humming at full steam, right? So it's we're like at full capacity, power prices are the highest at that moment. And so having a little bit of extra capacity to buffer off this peak power is a great thing, right? So, and that's what really this power plant is, what I assumed is kind of is meant for, right? So it's providing peak power when it's needed. So based on that, I came to the conclusion that it's easy, right? It's a great thing. Nice hydropower plants for a defined purpose, clean power. And as an engineer, I thought I had captured the whole idea about this energy system. but I was very much wrong, and I was glad that I went with somebody there on this tour who could tell me a lot of the difference and a lot of the other aspects that are part of this power system or this energy system. I don't know if you remember that day. That was in 2013, and what day was that? That was on, I don't even remember, the summer at some point, right? The major rainstorm that hit the western slopes of the Rocky Mountains. So you probably, maybe have seen the pictures of Canmore, like Cougar Creek being completely washed out. Maybe the pictures of the Trans-Canada Highway, bridges being washed out. Or here, this is the picture at the Barrier Lake spillway. So this is actually the Barrier Lake power station in the picture here, which I kind of grabbed from YouTube. You see there, that's the house where the power is actually generated. In the back of this picture, you see a little bit of a like a black kind of feature in the dike that kind of is the end of the Barrier Lake. That's actually the pipe that directs the water to the power station. You see here's all the electrical transformer and power lines on the bottom left of the picture. That's completely flooded. So there's so much water came down that time that it kind of destroyed a lot of infrastructure in the Kananaskis Valley. And TransAlta actually had a hard time saving the lake. You see with the water on the right-hand side, that's the spillway. So this is not the power, this is just the overflow. It's fully open and it kind of, so much water is coming out, it actually washed out the road that was there. And I'm pretty sure the white trucks that are up there, these are like the technicians from TransAlta. They're probably like, crossing their fingers that their dike doesn't break and that the water gets out of this thing, without causing too much damage. Anyway, the water went down the valley into the Bow Valley, down the Bow Valley, and it flooded Calgary. And there was still the internet is full of pictures of, like you see here, the Stampede grounds, how they were like hip deep in water. Parts of downtown were flooded, and there was massive damage around the city of Calgary. So obviously now, like, it came clear to me, like, and you can still see a lot of the damage in the Kananaskis Valley, actually, if you get somebody who points it out to you, like on the golf course, for example, there. So we want to have flood mitigation. That's a big part of this, water system that needs to be managed in the Kananaskis Valley. So whenever there's a rainstorm, they're hard to predict. We want to be able to catch as much water as we can, so to give us time to mitigate the flooding that will potentially come from this major rainstorm. So therefore, nowadays, Barrier Lake is actually kept almost empty. So if you go up to Barrier Lake right now, you will see a lot of gravel, little water. That lake is actually almost empty. And it really affects hydropower capacity that we can produce from that particular power station at Barrier Lake. So one constraint I didn't know, flood prevention is a big one. Then we drove up to a point on the Kananaskis River there, which is called the Widowmaker Rapids. That's what they looked like when I got there. It's very, quiet. You see this, I point out to the right-hand side, there's this big rock feature there, right? So that kind of sticks out. And it makes you wonder why it's called Widowmaker Rapids, because there's definitely no rapids, and the little bit of water that trickles down there is not very like widow-making kind of thing, right? So you can actually almost walk to these rock features just getting ankle deep into water. And I know we're told that this river is actually used for recreational activities and some industry down in the Kananaskis Valley. They make their living on tourists and using that river. So TransAlta actually accommodates that several times a year, several times a day. They're opening up their power station to create high flow events in the river. This is on the back of this picture. This is the same rock formation, and now it's truly a rapid. So they're changing the water flow from like next to nothing to like a meter or two in height. And that is primarily done for tourist reasons. So that, kayakers and whitewater rafting companies and so on can have their business in this valley. So interesting. I had no idea that this was also a constraint. There's even an app for that. You can look this up on the TransAlta website when the high flow events will be, so that you as an operator of these, you can plan your tours. And here's the the Pocatera plant that kind of regulates the flow in this part of the river. You see, that's the low flow event. It's when the water is like really like just hiking boot deep at this point and just a trickle. And in the bottom picture, you see the water. If you look at the rock formation there, the water level rises by 1.5 meters to 2 meters, like when they actually trigger the high flow event. And those high flow events are not triggered when the city of Calgary needs energy. That would be a coincidence. These are triggered so that people can use the river. So tourism is an important one. Then we drove up to the upper and lower Kananaskis Lake. And in the background, you see the mountains that have the glaciers that feed this lake. So now one thing I didn't realize is that in lakes like these where the water is very cold, there's only a zone in the depth direction of the lake where fish actually can feed, where plants are growing. So the water is just warm enough, but it's, it's still like and if they go too deep, the water is too cold and very few things grow apparently there, and fish can't feed. So if you cycle the water level too much, then this biozone that fish habitat needs is going to get destroyed. So, and actually funny thing is I have this little sign here that you can see at the shore. If you come at a low water level to the upper and lower Kananaskis Lake, you actually see things that look like island, but you can actually walk over to them on dry foot. If you come back later, you might see that the water level has risen like quite a bit, and these islands are now truly surrounded by water. So there's actually signs that if you walk out there and you don't go camping, you might not get back in a few hours later, right? So anyway, so because of the constraints that you have in the way you can cycle the water level, you cannot to protect the fish habitat there. You're also limited in the amount of hydropower you can produce at any given time. It's very interesting. And another thing I had no idea is we know already the impact that hydropower had. We know from historical recordings and from reports from native people who have been using this valley as their grounds for hunting and fishing, that there has been very different types of fish in that lake in the past. And so this has actually changed over the years due to the use of hydropower. And again, it changes the way the feeding zone or the biozone in these lakes develop. So again, and it's constrained that now TransAlta has to consider to protect the environment, the fish habitat in those lakes. So the water resource management means something much bigger than what I initially thought. I thought, okay, that we've just fill up all those lakes essentially with water and then let water run down through the hydropower stations to generate electricity when we need it. But no way, that's only a small portion of the big picture that needs to be considered when you look at this energy system. So there's flood mitigation, like the city of Calgary wants to have those lakes as empty as possible to catch flooding. You have tourism. People want to use this river for like boating and or kayaking and whitewater rafting. And you have environmental protection to adhere to. So making sure that you don't damage the fish habitat in those lakes. So overall, this has become or is a very complex energy system, seemingly very simple when I looked at it with my limited engineering view initially. But I learned that even something like that, like a small hydropower system, is embedded in a much, much bigger system that has a high level of complexity. And I think that's the my conclusion here. And so I'm going to pass it on to Amina again. Thank you.